plus Q minus Q. Then this plate X, all right, this plate Y. And let me join these plates by wire, conducting wire. I'll call that as a switch. After closing, I'll give charges, electrostatic induction occurs, redistribution charges till place, then I'm going to close switch. So there's an iron wire. Or a copper wire, I'll write it. And what are these? These are iron, no? Conducting plates. Let's see that. After closing switch, what will happen? Okay, first we'll begin like this. I gave equal and opposite charges. What will happen to them? Redistribution of charges should take place. Where the charges will decide? The plus Q here, minus Q here. Am I right? Then can we say anything about which plate is at higher potential? Yes, by looking at the field between the plates. So the field between the plates will be in this direction. We'll calculate the field at point, okay, A, we took it, no? What is the field at point A? What all we studied, all that you have to apply. What is the direction of field at A? Will be from X to Y, plate X to Y. So with this, what I can conclude here, no? Vxy. What is Vxy equal to EA into D? What is the separation between the plates? Let it be D. I'm able to predict potential, and from the looking at the data, Vx greater than Vy. I'm going to close switch. I'm going to join them by conducting wire. Now what will happen? Yes. A positive charge from where to where it will flow? From a region of higher potential to lower potential. Which plate is at higher potential? Plate X is at higher potential than Y. I think all these are more logical, no? We don't have anything like some mass integration, that one, just some method. The Gauss law, the net field inside content should be 0. A charge, positive charge will move from a region of higher potential to lower potential. I think all these, the things what we learned, we should apply systematically. The moment I close switch here, the charge which is there here, it will not happen. Now it's having a path. So it will start flowing like this. Why it should flow? Because there's a higher potential, lower potential. And we know conductor is an equipotential. So these are iron plates. They are at different potential now. I'll join them by copper wire. Copper is a conductor. So what this copper will do, we'll see that the potential of these two will become equal. How do they become equal? So positive charge should leave this plate X. How long the flow of charge will be there? Till both will acquire same potential. So charge will flow here. So plus Q, when it comes and deposits here, plus Q minus Q will become 0. Finally, what is the charge? Will be 0. Agreed? So what is the final charge on the plates? Will be 0. Next question comes. There was some energy between the plates, no? The electrostatic field is there. In fact, there is an electrostatic field. I'll show only few lines. The electrostatic field is there. Now, this because of electrostatic field, there's a field energy. Can we calculate how much of energy between the plates? I think this also we know it. This should be equal to half F0 EA square into ED. What is EA? Q by A F0 whole square AD. Now what is U? I should call energy between the plates. So which is equal to Q square D by 2A F0. Where do this energy gone? Because there is no electric field. Where do this energy gone? Converted as heat. Where? In the copper wire. So after closing switch, charge What is the reason we should give? What is the explanation? After closing the switch is the charge Q flows from plate X to plate Y through Y. It will be generated in the wire. So from where that heat energy will come? The energy between the plates will get converted into heat generated. Heat H will be generated. This heat generated should be equal to U. So all the energy between the plates will be converted into heat across the copper wire. Able to understand this one? So the energy that was there between the plates now will be lost. It will be converted into heat in the copper wire. Any doubt you can clarify?